Penicillin was discovered by accident. That is the story. Alexander Fleming went on holiday, left a petri dish out, came back, saw mold growing on it, and stumbled into one of the greatest medical discoveries in human history. Pure luck. Wrong place, right time. Except, the more I read about this, the less accidental it looks. Because Fleming had been deliberately hunting for something that could kill bacteria for years before that petri dish. He had already discovered lysosine in 1921, an antibacterial enzyme, by doing the exact same thing. Letting things grow and watching what happened to the bacteria around them. This wasn't carelessness, this was a method. And the contaminated petri dish, the one we say was luck, Fleming almost threw it away. He had already cleaned most of his dishes. He only kept that one because he happened to show it to a former colleague who stopped by the lab. If that visit doesn't happen, the dish goes in the bin. So if the discovery of penicillin wasn't simply a lucky accident, if Fleming had been looking for exactly this kind of thing and nearly missed it anyway, what actually happened? Let's go back to 1928. Fleming is working at St. Mary's Hospital in London. He's a bacteriologist. He has been studying Staphylococcus for years, the bacteria that causes skin infections, pneumonia, sepsis, stuff that was killing people before antibiotics existed. Every infection you now treat with a pill was in 1928, potentially fatal. Fleming goes on holiday in late August. Before he leaves, he stacks some petri dishes near his lab bench. He doesn't clean them first. He's going to deal with them when he gets back. Now, here is where the weather matters. London in August 1928 had an unusual cold snap, around 9 days of colder temperatures, before warming back up again. And that temperature sequence turns out to be critical. A Penicillium mold spore, nobody knows exactly where it came from, probably an open window, possibly the mycology lab 1 floor below, lands in one of Fleming's uncovered dishes. During the cold snap, the mold grows. The Staphylococcus bacteria can't grow in the cold, so they don't colonize around it. Then the temperature rises, the bacteria start growing, but by then the mold has had enough of a head start to release compounds that kill the bacteria in a clear ring around it. Fleming comes back, starts cleaning dishes, and, with a colleague standing next to him, picks up the contaminated dish to look at it before throwing it away. He sees the halo, clear zone around the mold. Bacteria dead, and crucially, he knows what he's looking at, because he had been looking for exactly this: an antibacterial substance that could kill without harming the surrounding tissue. When he sees the clear zone, he doesn't see contamination. He sees a result. He identifies the mold as Penicillium notatum. He names the antibacterial substance penicillin. He publishes a paper in 1929. And then almost nobody cares. The 1929 paper gets minimal attention. Fleming can't figure out how to isolate penicillin in a stable, concentrated form. It degrades too quickly. It's hard to grow in large quantities. He presents it at conferences. Other scientists aren't impressed. He more or less moves on. This is the part of the story that gets left out. The discovery and the drug are not the same thing. There is a 10-year gap between Fleming's petri dish and penicillin as medicine. The drug version, the thing that actually saves lives, comes from 2 scientists at Oxford, Howard Florey and Ernst Chain. It's 1939. World War II has just started. The Allied forces are dealing with a specific, brutal problem. Soldiers are surviving bullets and bombs and then dying from infections. Infected wounds, sepsis, gangrene. Same as in every previous war. Florey and Chain are searching for a way to make antibacterial substances that can actually be used on humans. They read Fleming's 1929 paper. They decide penicillin is worth pursuing. What they do next is not accidental. It is a sustained, deliberate, difficult scientific project. They grow Penicillium mold in every container they can find: bedpans, bathtubs, hospital trays. They develop a process to extract and purify penicillin, They run animal trials, they test doses, they figure out the chemistry of stability. In May 1940, they inject 8 mice with lethal doses of streptococcus. 4 get penicillin, 4 don't. The next morning, the 4 treated mice are alive. The 4 untreated mice are dead. Florey reportedly says, "It looks like a miracle." The first human trial is January 1941. Albert Alexander, a police constable in Oxford, is dying from a massive infection. He scratched his face on a rose bush. The scratch got infected. It spread to his eye, his lungs, his shoulder. By the time Florey's team gets to him, he has been in hospital for months, and surgeons have removed his eye trying to stop the spread. They inject him with penicillin. Within 24 hours, he is improving dramatically. His temperature drops. The infection starts retreating. For 4 days, he gets better. Then, they run out of penicillin. They were so short on supply that they had been recovering penicillin from his urine and reprocessing it. When the supply runs out entirely, Alexander relapses. He dies in March 1941. They didn't have enough of it, but they knew it worked. Florey flies to the United States in 1941 to find a way to scale production. American pharmaceutical companies, Merck, Squibb, Pfizer, start mass manufacturing penicillin under government contract. By 1944, there is enough to treat every Allied wounded soldier in the D-Day invasion. The U.S. Department of War estimates that penicillin reduced the death rate from infection among Allied troops from around 18% in World War I to less than 1% in World War II. In 1945, Fleming, Florey, and Chain share the Nobel Prize in Physiology or Medicine. Now, why does the luck story survive? Because Fleming told it that way. Fleming was a gifted communicator. He gave hundreds of speeches and interviews after the Nobel Prize, and the version he told was the accident version. The humble scientist, the fortunate contamination, the lucky dish. It was a better story, and it made him more sympathetic. He didn't claim to have done the chemistry that turned the mold into a drug. He credited Florey and Chain, but he also didn't fully explain that the discovery and the drug were separated by a decade of hard work he had nothing to do with, and the media ran with the accident. Because a lucky accident is a more satisfying story than a 1929 observation was eventually followed by sustained wartime industrial chemistry. There is also a deeper issue with the word accident itself. When we say Fleming discovered penicillin by accident, we mean the contamination was unplanned. True, but accidents happen to everyone. That particular mold landed on thousands of petri dishes in thousands of labs in the 1920s. Fleming was the one who recognized what he was seeing because he had been thinking about exactly this problem for years. Louis Pasteur said it in the 1850s. Chance favors only the prepared mind. Fleming's mind was prepared. The dish was not planned. Those are both true at the same time. What we call the accident was the raw material. What Florey and Chain did was the discovery that mattered to medicine. And what the American pharmaceutical industry did between 1941 and 1944 is what saved the lives. Fleming found something worth investigating. Florey and Chain turned it into a drug. The U.S. war machine turned it into a supply. All 3 things had to happen. The mold on the dish was the beginning. The story we tell treats it like the ending. The accident gave Fleming a clue. It took 15 more years, 2 other scientists, a world war, and an industrial mobilization to turn that clue into medicine. And we called the